This is the solution to example 4 from notes 3.4. And here we're going to put together a lot of things we've been working on in this unit. So we're given a polynomial function of third degree, and we're asked several questions. So the first question is, how many zeros does f of x have? So it has 3 because the number of zeros is equal to the degree of the polynomial. And remember, those aren't distinct zeros. Those are zeros counted, repeated zeros. Counting repeated zeros the number of times they occur. Letter B says, find all zeros of f of x, then write f of x as a product of linear factors and quadratic factors that cannot be factored. That's normally how we factor things over the rational numbers. Use the rational zeros test and synthetic division to help you find zeros. So in the previous section, if we were given a cubic, we were always given 1 zero or one factor to help us get started. But here we don't have any information. So what we're going to do to start part B is we're going to get a list of the possible rational zeros using the rational zeros test. So P, in this case, are going to be factors of the constant term, which is negative 28. So we're going to find factors of negative 28. And Q is, values for Q are factors of the leading coefficient, which in this case is 1. And remember, that's a lot easier because we're just dividing by plus or minus 1. So I'm going to start listing the the factors of negative 28. So that's plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 7, plus or minus 14, and plus or minus 28. And the factors of 1, which are Q, is just plus or minus 1. So our list of possible rational zeros, our complete list. Remember, this is just rational zeros, not all possible zeros, because we could have irrational or imaginary zeros, is plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 7, plus or minus 14, plus or minus 28. That is our list of possible rational zeros that we're going to use. So we're going to take this and we're going to start with synthetic division. And when we're doing synthetic division, we're trying to get a remainder of 0 because that means we found a 0 and a factor. So I'm going to go ahead and write the coefficients across the top row. So those are the coefficients from our polynomial function here. So it's 1, negative 2, negative 1, and negative 28. And if we can find 1 0, we'll be in good shape because we're starting with a third degree polynomial function. If we find 1, we can reduce the quotient to second degree, and then we'll be able to solve that. Okay, so I'm going to put the coefficients in. So those are going to be 1, negative 2, negative 1, negative 28. There's no missing terms, so we don't need any placeholders. And I am going to try a 0 at 1. So let's see if 1 works. So we're going to bring down the 1. 1 times 1 is 1. Negative 2 plus 1 is negative 1. 1 times negative 1 is negative 1. Negative 1 plus negative 1 is negative 2. 1 times negative 2 is negative 2. Negative 28 plus negative 2 is negative 30. So this one is no. That does not work. So 1 is not a 0. So we'll try another one. Let's try 2. Let's see if it works. So 1, negative 2, negative 1, negative 28, putting the coefficients in. Bring down the 1. So 1 times 2 is 2, negative 2 plus 2 is 0. 2 times 0 is 0, negative 1 plus 0 is negative 1. 2 times negative 1 is negative 2. And again, we're going to get, this would be negative 30. So no, 2 is not a 0. Let's try another one. I'll move up to the next positive number and hope that we find something. So I'm going to try that. So I'm going to try 4. So 1, negative 2, negative 1, negative 28. I'll bring down the 1. 1 times 4 is 4. Negative 2 plus 4 is 2. 2 times 4 is 8. Negative 1 plus 8 is 7. 7 times 4 is 28. Negative 28 plus 28 is 0. Yay! We found a 0, so we can conclude that 4 is a 0 and x minus 4 is a factor. And we can also begin factoring this polynomial because we know that f of x is x minus 4. That's the factor we just confirmed. And then we can use the coefficients of the quotient Oh, those are the coefficients of the quotient, I should say. And it's going to be second degree because we started with the third degree. So this will be x squared plus 2x plus 7. And now, unfortunately, x squared plus 2x plus 7 can't be factored. So we can solve this by completing the square or by the quadratic formula. I will use quadratic formula this time. So I'd have negative 2 plus or minus the square root of b squared, 2 squared, minus 4 times a is 1 times c is 7, all over 2 times 1. So that's negative 2 plus or minus the square root of 4 minus 28, which is negative 24 over, this denominator is 2 times 1. Negative 24 over 2. So it's negative 2 plus or minus. Negative 24, I'm going to pull out an I. And 24 is 4 times 6. So I'm going to pull out 2i, leaving us with rad 6 over 2. And then we can divide all of the terms by, or divide everything by 2. So that'll leave us with negative 1 plus or minus I rad 6. So our goal was to write the zeros. So we have 4, the first one we found, and then negative 1 plus or minus I rad 6. So we found 3 zeros. And I'm going to scroll back up to the question. So what were we supposed to do? We're supposed to find all zeros. So we just did that. And then we're supposed to write f of x as a product of linear factors and quadratic factors that cannot be factored over the rational numbers. And we actually did that already. That was our answer here. So this is a product of linear and quadratic factors that cannot be factored. So that's the end of part B. And then part C asks us for something that we haven't done much of. It says, as a bonus, factor f of x is a product of linear factors. So that means that each 0 is going to yield a factor of the form x minus k. So part C, we can write f of x is equal to x minus 4. And then we have the zeros at negative 1 plus or minus I rad 6. So we can write a factor of x minus negative 1 plus I rad 6. And then we'll also have the second one, x minus negative 1 minus I rad 6. And that's correct. If we wanted to, we could simplify this a little bit. We'd have x minus 4 times x plus 1 minus I rad 6 and x plus 1 plus I rad 6. So that is the function written as a product of linear factors.